Hello, and welcome back to lecture 9. We're almost there, you guys. So in section, chapter, module 9, we are going to talk a little bit about database systems. And again, this is one of the things I kind of like, one of the topics that is in my wheelhouse in computer science. So we are going to skip sections 4 and 5, and we're going to concentrate on 1 through 3 and 6 and 7. So let's get right on to it. So first things first, what is a database? So a database is a collection of data, and it is different than your flat files in that there is some sort of relationship between the entries or between the sets of data. Here there is like a formal definition which says it's a collection of data that is multidimensional in the sense that internal links between its entries make the information accessible from a variety of perspectives. So basically what it's saying is there is some sort of relationship within the data that it makes sense why they're connected or how they're connected. And that's, in essence, what a database is. This graphic over here shows two different ways. So you've got a file-oriented information system. Typically, this would just be files of a specific type. Maybe in this case, we've got different departments. So that department keeps all of their files in a specific location. Now, we can translate that into a database by having all of those files be able to connect and talk to each other so we don't have redundant information. So that's where we've got our integrated database that has all of the information needed by all of the different departments, and those departments would just be able to pull and access the data that they require. Now, a database has got to have some kind of plan or some kind of roadmap. We call those a schema. So a schema is the description of the structure of how the database is put together. Okay, this is typically used by database software, and it's used to maintain the database. Now, a sub-schema, on the other hand, is a description of a specific portion of the database pertinent to the specific user's needs. So, for example, in the previous slide, we said there were several different departments that accessed the database. The sub-schema would be what the finance department sees, what the security department sees. Okay, so you can see that there's slightly different views and different access points in the sub-schema, whereas the schema itself would be the entire integrated database and how it is set up. So the sub-schema is used to prevent data that should not be accessed by certain people to not be accessed. So it is used for security and for breaches and things like that. So you can limit access by using a sub-schema. Now, we've talked in the past about a DBMS, a database management system. That is going to be your software layer that integrates with your user. So it's going to communicate with the database on the back end and with your user on the front end. It makes it a little bit more enticing and graphically, pleasing to the human while being able to do the nitty-gritty in the background. We've got something called a distributed database. So this is a database that could actually be stored on several different machines. It could be in different locations. It can be in different countries, for all we know. So the DBMS is actually going to mask, and we talked about masking and keeping the nitty-gritty from the user when we talked about abstraction, right? So the DBMS does a form of abstraction. It's going to basically hide all of those details from the user. So your user will not know that they selected names from North Carolina and then selected job tasks from North Dakota. Your user won't even know that. Your user won't care. So data independence is the ability to change the organization of the database on the back end without having to change anything from the DBMS side. So here is a graphic of sort of the partitions that are in the different steps. You've got your user, and your database is seen as an application. Your database is going to show data and use it and be able to select and things. Your user may not even know that they're accessing a database. The application software, this is what is going to make it look pretty. It's going to be its look and feel and where buttons are. And the application software is then going to talk to the DBMS. Sometimes these are integrated, sometimes they're not. The DBMS is then going to be your basically mediator between your actual database and what the user sees. So you can, the worst case scenario, it would be broke up into 4 different parts. Best case scenario, there's typically 3, with the application software and DBMS being one and the same when it comes to the actual software. A database model, this is going to be your conceptual view of the database. Okay, it is going to be how we draw it on paper, how we see it in Word on the computer. There are 2 different ways that we can access a database model. We can have a relational database model and we can have an object-oriented database model. And we're going to look at both of them a little bit closer right now. Now, the relational model, this is going to show up more as a table and what we are sort of traditionally used to seeing in a spreadsheet type of way. So your table is going to have things called attributes, which are the column titles, and you have a thing called a tuple, which is actually the row. So the tuple is your set of varying information, where your attribute is your set of all the same information. If that doesn't make sense, just ignore me. There are issues that come with the relational design of a database. You need to avoid multiple concepts within one relation. You can lead to redundant data. The whole point of a database is to eliminate redundancy. We want to have data in one location. We want to access it only once. If we want to update it, we only want to update it in one location. The other thing that can happen is that deleting a tuple could also delete necessary but unrelated information. So, that tuple maybe have been needed for something else, and that may get screwed up when you're looking at it from the other point of view. Now, you can improve on relational design. So you're not just going to take any spreadsheet and table and throw it in a database and say it's the perfect relational database. It's not going to be. So there are certain things that you can do. You can do something called decomposition. And this is going to divide the columns into relationships of 2 or more, duplicating those columns necessary to maintain the relationships that you need. So when you're looking at these, here in this table, for example, in the blue, we've grouped all of the employee pertinent information, which is the ID, their name, the address, social security. And then for the pink, we have grouped together all of the job information, like the job ID, job title. So this is called decomposition. You're grouping like attributes together in order to sort of look at those relationships. Now, a lossless or non-loss, decomposition is basically a decomposition in which you don't lose any information. The whole point of decomposition is not to lose information, right? What you're trying to do is remove the redundancy. So again, if you look at this graphic, you've got in the blue, you have a duplication of Joe E. Baker. Okay, we don't want to duplicate Joe Baker here at all. And then in the pink, you can see he's duplicated because he's had 2 different jobs. Okay, so looking at this, there's got to be a way to organize this structure in a way so that Joe is not duplicated. And over here, we've got a job ID to where that job ID is not duplicated. So in this example, we can see that we can actually pull out 3 different tables, okay? I call them tables. They're actually relations. So if we look, we've got the employee relation, which is a singular employee. Notice duplications are gone. Then we've got a job relation. And again, each job title, job skill, and department is only there a singular time. Now, the new part of this is going to be that assignment relation, and that is going to be the table or relation that is going to connect the employee to their job. So if you look down here, you've got Joey Baker. Oh, well, they took Joey Baker off. Okay, so you've got Jerry Smith, which is the 23Y34. He had 2 different jobs, the one at the very top, which is the S25X, and then he moved to the S26Z. So you can see here, we're not duplicating any information in this bottom. Okay, so you're taking the employee ID and the job ID and then just adding the start and finish dates. That's really the whole goal of a relational database, is you want to make sure that you have all the information, you're not losing any information, and you're not duplicating. So if we want to find the department in which the employee has worked, we're going to go down to that assignment relation and pull out all of the job IDs that have that employee ID equal to the 23Y34. Here we can see there's going to be 2 different job IDs. Then we can take that job ID and look in the job relation table and then find the department directly. Again, very easy to do. There's just might be another step or 2, but we do have ways of consolidating those steps down. We'll look at that in a little bit. So here, this is an example of a relation and a proposed decomposition. Okay, so our original relation had employee ID, job titles, and departments with things duplicated and multiple lines that just had lots of information. The proposed decomposition of that is to have an employee ID with a job title and a job title with a department. So you're breaking that relation up into 2 separate relations that are being connected by that job title. So you can see you're still connecting the information, but you're using one of the attributes instead of multiple. Some relational operations that you can do, you can select. So a select statement is going to select the data or choose the rows. You can project, and if you project, you're going to choose the columns as opposed to the rows. And then finally, you can join, which means you're going to put things together, just like it sounds. So you're going to assemble information from 2 or more relations. So there are 3 basic operations that we're going to be talking about and looking into: select, project, and join. And remember, only difference, row, column, and putting basically everything together. Now the select operation, what you can do is, this is called SQL, we're going to talk about it in a little bit, but you can put together some syntax that says select from employee relation where my employee ID equals a value, okay? So what that's going to do is it's going to take all of the records in there to where the employee ID is equal to that value. And it's going to create a new relation, and that new relation is going to be all of that information for that employee. Now the project, remember, this is going to select a column. So what you can say is project name and address from the employee relation. So it is going to create a new table, and it's just going to be filled with the name and the address columns only. You're getting rid of employee ID and social security number. Finally, the join operation, you're actually going to take data from 2 different positions and make them into one. So here I'm saying join A and B, which are going to be my relations or my tables, where the A's W matches the B's W. So what I'm getting is a whole new relationship with AV, AW, and then BX, BY, BZ. Okay, so you can see how it's taking those 2 tables and making a third out of it by using the word join. Application of the join operation, just as like a working application. So here we want to put together a large table that has the assignment and the jobs where the IDs are equal. So everybody that is assigned to every single job, okay? So here it's going to say join assignment relation and the job relation, or the tables together, where all of my job IDs are equal in both tables. So you can see the new relation happening at the bottom as a table, and it is giving me all of the assignment relation information in the front and all of the job relation information at the end. So it's giving me all of the attributes from both tables. This might be necessary in order to find information when it goes across tables. Now here, we're going to talk about SQL. That's what we just talked about with the join and the project and the select. So typically SQL is called a structured query language. It's how you talk to databases. It is an industry standard type of language. Now, if you remember our lesson on programming languages, it's actually quite a high-level language. And what it does is it's going to manipulate those relations and the tables. So operations to manipulate the tuples. Remember, a tuple is a row. So you can insert a row, update, delete, or even select. There's our select a row. Here's some examples. Don't go crazy into this, and you don't have to go, really don't have to know anything more than what we've talked about when it comes to SQL, but I wanted to show you just as an example of what an SQL would look like. So the first one is saying select, and it's giving it some attributes from the table names where something is happening. So we've got select the employee ID and the department from the assignment table and job table, where the job IDs are equal and the termination date is a star. Okay, you can do the same thing when it comes to insert, and again, this is just so that you can see it and be able to recognize it. You're not going to be asked to write any SQL samples. Here we can say insert into employee, so we're going to be inserting a row into that table, and the values we're going to give it are found within those parentheses. We're going to give it an ID, a name, address, and a social security number. More, we've got delete, and then we have update. So delete from that table, Jerry Smith, they're fired. They no longer work here. Or we can update it on the employee table, update an address because Joe moved. Okay, again, super simple. Do not get in the weeds of the SQL. It's just for you to be able to recognize that that is SQL, and it's actually quite easy to read if you just read it from left to right. Now, the other type of database that we have available is an object-oriented database. And it is a database constructed by applying that whole object-oriented paradigm that we talked about before, where everything is self-contained within an object. Remember, self-contained means objects and actions, right? We're putting them together. So each entity stored as a persistent object. The relationships are indicated by links between these objects. The DBMS is going to maintain the inter-object links. So the object is able to keep track of whatever it needs to internally, and the DBMS only has to deal with the external. So here, for example, we've got a few assignment objects. Okay, so we've got an employee working 3 different assignments. Each assignment has an associated job to it. So the DBMS would be concerned more with those maroon arcs and circles than they are actually within the boxes. The boxes themselves are going to be your objects, and so they're going to know how to deal with themselves accordingly. Now, some advantages of the object-oriented databases is that it does match the object-oriented paradigm of applications, and that seems to be the way that people are pushing and trying to go in that direction. Your intelligence can be built into your attribute handlers. So your attributes, remember columns, are going to know and have a little bit better understanding of what's going on internally. So the other thing is that it can handle exotic data types. So such things as multimedia, such as an audio file or a video file. These things aren't typically easily stored in a relational database. Relational databases are much better geared to primitive data such as numbers and text, dates, times, things like that. But multimedia does kind of give it a little bit of a problem. So let's switch from the database into data mining. So data mining is an area of computer science or information systems, and it's going to deal with discovering patterns and collecting data, okay? So the data mining is going to be used, a lot of times it's used in marketing type industries. That's a word. So we're looking at collecting and looking for patterns. Data warehouses is typically a static area of just pure raw data collection that needs to be analyzed or mined, okay? So when we talk about data mining, we're talking about analysis. And a data cube, on the other hand, is data presented from many different perspectives in order to get some additional information for that data mining. Now, some data mining strategies is different ways that we can look for those patterns when we're doing this analysis. So we have class description, we've got class discrimination, we've got cluster analysis, we've got association analysis, outlier analysis, and sequential pattern analysis. Some of these a little bit more obvious than the others, like cluster analysis. We're looking for where that data is clustering, and we can figure out why it's clustering in that location. Again, if we're going to look at marketing, if we're going to do a cluster analysis, we can say we're Amazon and say, okay, everybody that bought product A, they also bought product B. So if anyone's looking at product A, we may want to advertise product B to them as well, okay? Kind of goes along with association analysis, okay, if you buy product A and product B. Outlier analysis is looking at those guys on the outside and seeing what they're doing and why they're doing it. And sequential patterns is, is there a pattern of if they go to website A, they go to website B, and then they eventually go to website C. So it's looking across the board at that data to see and hopefully predict what these people and these users are going to do. So finally, that does bring us into the social impact of database technology. So the problems associated with this type of technology is that there are massive amounts of personal data available out on the internet being collected, often without knowledge, without any kind of information as to why it's being collected, and without the consent of people. Data merging produces more and new invasive information, and there might be associations that are created that just aren't there, just based on the data, okay? So errors can be widely disseminated and hard to correct. Now, some of the remedies because of these problems are going to be, legal remedies. They are most of the time difficult to apply. A lot of people get around them by going outside of the jurisdiction, such as different countries even. And, one of the biggest remedies could possibly be just negative publicity for that organization. When you hear that an organization has had a data breach, kind of makes you think a little bit more negative on that organization than it did before. So this was a quick, easy, very, short and to the point lecture on databases. Please don't get involved too far in the weeds in the SQL. It was just kind of to wash over you and let you know what it is, and so that you may recognize it if you're confronted with it in the future. As always, if there's any questions, comments, concerns, please email me. I'm here for you guys, and I will see you next time. Bye.